Okay, so now let's try to use these pKa values to determine equilibrium. So for an example, let's go ahead and use one of the amines that we just talked about. So this amine right here, NH2, we're going to have a lone pair right here. And let's see what happens if we combine this amine with, let's just say, hydroxide. So hydroxide, we've got 1, 2, 3 pairs of lone pairs. And what we're going to have is an acid-base equilibrium between the two of these molecules. So in this case, it's relatively simple to try to figure out which of the molecules is going to be the base and which is the acid, just by taking a look at the charges. So the hydroxide is negatively charged. More than likely, it's going to be our base. Okay, and if you think about this NH2, this is probably going to lose a hydrogen. So let's go ahead and show a box where we're going to put in our arrows. And if we assume that the hydroxide is our base and the amine is our acid, let's go ahead and draw the products on the right. So go ahead and pause the video and try to predict the products. Okay, so what you should have shown was that this nitrogen would have lost a hydrogen. So it would have one less hydrogen and one more lone pair. And in this case, we'd get a negatively charged molecule. And so then if we lost a hydrogen from the amine, we're going to gain a hydrogen on the hydroxide. And so this molecule will actually end up turning into an H2O. Okay, so now if we were to draw the mechanism like we did in the last lecture, we could redraw this amine and we could show physically the covalent bonds. And if we actually wanted to show the bond making and the bond breaking, you would show these electrons coming over, making a new bond, and then you would break the bond between the nitrogen and its hydrogen partner. Okay, so this is where our other lone pair came from. So this bond right here is where we get this extra lone pair right here. And then these electrons right here are going to be what we have forming a new bond between the oxygen and the hydrogen. So if I wanted to erase these, let's go ahead and erase them to show that bond formally. Okay, so we've got hydrogen here and here. And so these yellow electrons are actually being used to form this new bond right here. Okay, so now that we've drawn out the mechanism going to the right, we can still, we can actually predict which side of the equilibrium will be favored just by using pKa's. Okay, so the pKa's that we're going to want to use are going to be the pKa's for the acid on the respective side of the equation. So between these two, the amine is acting as the acid. So we're going to use that pKa in our process. So this one was 40. And if you go from right to left, the water is actually acting as the acid. So it's giving up this hydrogen to go back to its original state. And so the pKa for the water is just like the alcohol, it's basically the same. It's going to be 15. Okay, so now again, with this process, we had to do a couple of things. We had to predict the products. We had to figure out, okay, what's acting as an acid on either side of the equation. And now what we're going to do is we're 99% done. All we have to do is now figure out which acid is the weaker acid. So again, the lower the number is, the stronger the acid is. The higher the number is, the weaker the acid is. So of the two, the amine is the weaker acid. And for predicting equilibrium, all we have to do is remember that equilibrium favors the weaker acid. So what we would say then is that equilibrium is going to go majority to the left, because according to this rule, equilibrium is going to favor the weaker acid. And so what we're going to have here is that the majority of the time, this amine is going to be in this state. And a very minority of the time, the amine is going to be in this state. Okay? And that's it.